Okay, so as we get started, this is where we left off with yesterday, and we'll be making a reference to your book. And excuse me, as you notice, some of these have common names, and some of them you can use the scientific name then as well. And that's not what we want, is it? Come on. There we go. Maybe. Oh, then, yes, we were gone for the cross-country meet, so now someone else hooked their computer up here, which is fine. That's what I wanted them to do. We'll get this going at some point this morning. We'll try that. And Yahtzee. There we go. So the common name is given second, okay? Because we briefly discussed this yesterday. If you just have methyl group on a benzene ring, you can just call it methylbenzene, or its common name before the IUPAC system would be toluene. Same thing with, if there's an OH group, it would be phenol. Then moving forward, there's one that's not on here. I see it's aniline. So we will discuss that in a few moments. For some reason, shouldn't this fill the entire screen? Huh. I'll have to explore that. So this isn't going to mean anything to you right now, because that's going to be more so next week, but we want to get you ready for that, because your assignment is going to entail this tomorrow. Because sometimes you may choose, you want to use this numbering system, and these match up with this numbering system, where the letter O for ortho lines up with 1 and 2, meta with 1 and 3, and so on with para would match up with 1 and 4. And when you're writing these compounds down as we started, that's where you would possibly use some of those. It just makes it a lot easier, a lot quicker, a lot shorter when you're writing these out, should you use this type of an abbreviation. And it's not like it's a lot, but some people still choose to do that. So does anyone possibly remember what a carboxy group would possibly be? That is COOH, where you can see it written in that designation, or a carbon with a double bonded oxygen and an OH group. Okay? And some of you may have noticed that both designations were up there on the board when you were writing those down. Okay, let's see here. I want to do, let's see here. Okay. We'll do this, and then that'll be it for today, because when we get to this, these are the reactions that accompany these compounds. Just like you remember, we started talking about the alkenes, naming them, then we started moving on to the reactions. We follow a similar pattern where we're naming these, and then we'll move on to the reactions. Okay, does everyone have this content that is choosing to write this down? Okay. So we then can proceed. Holy cow, we're making good time here. Maybe we better slow down. That's all right? Okay. All right.
See how efficient we are compared to other schools. Yeah.
Okay. Can't argue with that. Well, we could. Isn't that what young adults do all the time anyway? Don't you argue? You don't argue, do you? Oh, no, not really. Okay. So, let's see here. Oh, these are saturated. We don't want those. I just want to make a quick reference to, let's see here. If you look at the bottom of page 351, okay? Now this is, that very bottom reaction, is that an aromatic carbon chain or an aliphatic carbon chain at the very bottom? We hear aromatic. Is it possibly aliphatic?
How can you tell?
Okay. Aromatics are the rings. Those are the ring structures. Okay. Aliphatics are straight chains and branch chains. But what I wanted to point out is when next week, when we probably have an evaluation on this, that meaning the naming of aliphatic alkenes and the reactions that accompany them, when you're communicating with this, okay, we see we got butene. So we say, is that a type of symmetrical reagent? No. Symmetrical compound or asymmetrical? Okay, it's asymmetrical because that double bond is on the end. Then when you react that with water, even though you have an oxygen in the middle, the color coding is showing you that it's not a space symmetrical. Rather, it is the asymmetrical. So when that happens, we know we get two products, just like some of those prior examples. But sometimes you get the same product and you don't have to label those. But with this one, where you have the conditions just right, the asymmetrical compound, the asymmetrical reagent, you get both a major and a minor product, and that's why I think we maybe just wrote that a couple times, circled it, and just said, okay, when you have that, you're going to want to label those as major and minor products. That's where that comes from. Okay, so now we can go ahead and look at some of these aromatic namings, and that is looks to me like it's 360. And you see a whole bunch of aromatic compounds there. Okay, so the first two we already talked about yesterday, that meaning phenol and toluene, and you could use the scientific names if you wanted, methylbenzene, hydroxybenzene, carboxybenzene as well, or you can call it benzoic acid. And then the last one that was up here yesterday that we just never talked about was this one. You can call it aminobenzene or aniline, okay? So if you're wondering where that amino comes from, this is something that you learned. We're just applying it now. From last spring, I don't realize that was a while ago, this is an amino acid because you have an acid side here, and then you have an amino side here, NH2, so that same pattern goes to these aromatics then too. So you can call it aminobenzene or aniline. All right. So, and there's a lot of, it's just, we're going to be doing the same thing, probably what they are talking about in this reading. I just wanted you to see some of these examples that If you like that abbreviated system, that only works when you have just two derivatives. But the common name can always work. Okay? Now that's something hard to wrap your head around here. So this is what we mean. One of the very last things I think that you wrote down in your handout says, notice that this only works when there's two derivatives or two substituents or whatever on your group. So we can't use that ortho, para, meta for this one. And of course, you can't use it for this one because there's only one organic family draping off of this, or derivative. Well, it's not a derivative, that's the organic family. You could use that abbreviated system for this one and this one. And do you think you can use it for this one?
No.
You can. So we're kind of combining two complex terms at once, okay? Because what we want to do, of course, we already know that this is aniline, and we don't have any of those compounds on here. But just like everything else, you want the lowest combination for all of these, okay? Do you just want to go in a particular order, or I just figured this is where you'd want to start, okay? So then you wouldn't start here. Here you would, okay? Of course, you notice that some of these looks like they're written at 12 o'clock, and that's, if you had to draw aniline like this, you probably wouldn't put it down here. You'd probably put it up top, just like this and this. But in this case, sometimes we're going to put these on the side. So if we assign this one as number 1, and then this one as number 3, is this not? Looks like this marker's already had it. Okay. So with that, is there a shorter designation that we can do with numberings? There's no 1, 3?
That's on the one. Unless you did the abbreviated.
You can do the abbreviated form for that, yes. Okay? So that's...
But is it wrong if you don't?
It's not wrong if you don't. It's the same thing.
It'd be meta.
Exactly. Okay? So if you like the numbering system, that's fine. We have 1 and 3. You would do 1, 3 dash. How many chlorines do you have on there? You got 2. Okay? So we've accounted for these, and then the parent chain is what? It's all of these are going to be benzenes. Okay? But let's say if you wanted that to be shorter, you said it earlier, it's not ortho, it's meta. You could do meta dash dichloral benzene. Because this means 1, 3. So those mean the same thing. But maybe you just want to pick a system and stick with that.
You don't even have to write meta out, you just do N.
Mm-hmm.
So that's why it's like, just opened up.
I heard it, but I didn't see it. Is that mind-blowing? Was that the... Oh, see, maybe that's why I don't have any hair up here, because I just do so many mind-blowing thoughts. No, not thoughts. What's a better word than that? Not expression. Activity? No. It's all good knowledge. I don't know if that falls in that category. Anyway, moving on. Okay, I guess we don't need to hear that. The emails coming in, because we'll probably have the announcements coming as well. So let me mute this one too. That one, I think. Okay. So does this one have a common name?
Wait, that one we just did?
Oh, I'm sorry. I pointed at this one, but you said go across the top, didn't you? Yeah, I swear I'm listening. Okay, hopefully we caught ourselves. But the same question would apply. Does this one have a common name? This is probably one of the more difficult ones up there.
No, because there's 3.
That's true. There's 3. The abbreviated system does not work. You can't use this because there's 3 on there. This only works if there's 2 derivatives or something branching off of there. So since this one has 3, you can't use any of this designation system. You have to use numbers instead. But you can use a common name for this. And what would that common name possibly be? See, this is what makes organic chemistry so complex, perhaps, and difficult. Okay. Well, let's back up then. Okay. What would we have here now if we cover that up?
Natural gas.
Nope, not natural gas.
Or, no. Is it
Nope, not aniline. Toluene. Okay. I think you pronounce it toluene. It might be toluene, but I always like to say toluene. Okay. So the same thing could apply here. Once you say that this is toluene, which is fine, that means that this methyl group, you'd have to pick one of those. That means that this methyl group would be your first carbon. Okay? And you might say, well, what about if we want to just use numbering systems? Well, that's fine too. You can do that. But if we make this a toluene molecule, okay, that means this one we would pick as number 1. Okay? So then where are our derivatives located on if the top is number 1? Okay? That's true. Are you using just numbering only?
Yeah.
Okay. Now that's a good question. You just say, yeah, okay. Well, all right. Just want to make sure our microphone doesn't go dead. So the front row is saying this, which is not wrong. We're saying, okay, 1, 3, and 4.
Can you use meta and then 3?
No,
So
you
can't
cannot.
combine them, can you?
Can't combine them.
Okay.
Nope. So then what you're saying is 1, 3, 4 dash what? Trimethyl benzene. We can shorten that up, okay? And how we can shorten that up is if, again, we assign this as number 1 being a toluene molecule, then what that is saying is that on the 3rd and 4th carbon, okay, you could say we've got 3, 4 dash, not trimethyl anymore. You would say dimethyl. Then what? Now it's not a benzene, but the common name. Yep, those mean the same thing. Okay? Now, what you might be thinking is, well, what happens if we wanted to make this one the toluene molecule? Well, then we've got 1, 2, and 4, which is fine too, but you just need to pick one if you're going to do that toluene. I'm suspecting that might be one of your questions. Okay.
So it doesn't matter how big the number is?
In this case, no. Not if you're going to use a common name. For our purposes here, yes, this is what we would want to do right here.
So like you don't necessarily have to make 3 and 4, 1 and 2, and then the 1 and 4.
Correct. Okay. Okay, now the most difficult one's done. The far one on the right, you can say carboxybenzene or benzoic acid. Okay? I highly doubt anyone's going to do anything other than this. I don't know why you'd want to call that carboxybenzene, but you can. Okay? We'd probably just refer to that as just benzoic acid. Okay? Then this one here on the bottom, do we like the abbreviated system?
Yeah.
Okay.
I feel like we should just try it.
You just want to try the abbreviated one. Okay. So when you do that, you can really shorten that up. Is this methylbenzene in your mind, or is it toluene? Okay. So once we say that this is toluene, here's number one. Okay. So then we got this chloral halogen derivative 2 spots away on the third. So you could do meta-chloral toluene. That's an appropriate name. You could also do, since it's 2 spots away, you could do 3-chloral toluene. And then, of course, there's one more you could do. You could also say, well, we've got, you could say, now if you call this benzene instead, then you're going to have to do some alphabetizing. Because then, I know, right? Then you'd have to do 1-chloral, 3-methyl benzene. Okay? But that's sometimes there's these from my interpretation, the IUPAC and naming all of these, it's constantly evolving and changing. Okay? So regardless of whether you call this a benzene ring or toluene, it's still going to come out the same. You're still going to be able to put them in the appropriate spots. Okay? Then finally, our last one here. What type of benzene is this? Okay? So what type of organic family is that?
Carboxy.
Sometimes it's written like this. Sometimes it's written like this. These mean the exact same thing. Okay? So with that being said, do we like the abbreviated form of writing these?
Yeah.
Okay? So then this would be the exact same. It's going to be a meta compound because once you say benzoic acid, you are assigning this being number 1. 2 spots away, we've got a halogen derivative or chlorine. So then it would be meta-chloral benzoic acid. Okay? Or you can, again, just say we've got 3-chloral benzoic acid, because it's 2 spots away, because you're using the common name. But then if you go back to the scientific name, then you're going to have to alphabetize those. So there's a system that you're always going to try to remain consistent with these. So how would this change if we just did that? It's still chlorobenzene, it's just in a different position. It's 1, 2 or orthochlorobenzene or benzoic acid. So then if we wanted that, and where's 4 located from here?
The middle bottom.
Yeah, right across the,
Oh, yeah.
yep. Oh, That's why I was interpreting you meant. It's straight across then, and then just attach it like that. Then you'd have parachloral benzoic acid. And that's what they're illustrating there on page, excuse me, page 360. So I just thought it might be a good idea to roll through those. Last thing we'll do is if you look at page 361, okay, where you see examples 12.11, we're going to disregard letter F. Which ones of those, A through E, does not work with an abbreviated system? C, you cannot use an abbreviated system. In D, you can't as well. Why is that? Because you have 3 branches off of there. So what about C? Does C have a common name? Yes. It's either aminobenzene, well, that's not the common name. You either say aniline, because it's NH2, and what about D? Does that have a common name? No, it does not. It doesn't have a methyl group, it doesn't have an NH2, it doesn't have an OH, and it doesn't have a COOH. Okay. So, and just to make sure that this one is probably one of the tougher ones that we began with, because when you see the solutions at the bottom, so for letter A, you could call that either meta-diethylbenzene, okay? Or you can use the numbering system. These abbreviations you can use at any time if there's 2 derivatives on there, okay? Or you can just use the numbering system. Because this doesn't have a common name, neither does letter A. I think that's a lot to wrap your head around, so we'll try to take this slow so it's hopefully not so overwhelming. Regardless, we will catch up with you next time.